Hello friends, welcome to my channel. In this video I will cover Isro 2017 mechanical. Question is, a simply supported beam of length L is subjected to a varying distributed load sin pi x by L, unit is Newton per meter, where distance x is measured from the left support. The magnitude of vertical reaction in Newton at the left support is how much? It's a simply supported beam. Let the points are A and B uniformly subjected to varying distributed load. So load will be like this. Then x is the distance measured from left support. Let this point is x point at 1 1. Then magnitude of vertical reaction n at the left support, or our A value we have to calculate, reaction at A point. So load given in this question sin pi x by L Newton per meter. So total load is integrated. Total length is L. From here to here, total length is L. 0 to L sin pi x by L dx. So sin pi x by L you will get minus L by pi cos pi x by L. Limits are 0 to L. So minus L by pi cos pi is minus 1, then minus of cos 0 it's minus 1, then you will get minus 2L by pi. This is total load. This is simply supported beam. So load is equally distributed. So RA equal to RB, its total load divided by 2 minus, it should plus 2L by pi into 1 by 2, you will get L by pi. This is your answer. L by pi, D is your option. Question is, a pin jointed uniform rigid rod of weight 981 Newton and length is 1 meter and is kept horizontal by an external force as shown in the figure below. The force F is removed suddenly. At the instant force of removal, the magnitude of vertical reaction in Newton developed at the support is close to. So first mark the points. A point, midpoint take as B, your load point at C. You are removing the load suddenly. So if you remove the load suddenly, load will act here. It will rotate like this. Load will act here, this direction, and reaction this direction. This reaction value we have to calculate. RA equal to this value we have to calculate. So first, for a rod we know moment of inertia for a rod. Here at center you will get ml square by 12, and at end point you will get ml square by 3. This one already discussed. So you apply here mass moment of inertia at C point, you will get m. Let the length is L, ml square, it should square, ml square by 3, or mass you can write W by G L square by 3. Then torque you have to calculate. Torque is W into distance. distance is here L by 2, total distance is L, so L by 2 W into L by 2, it's equal to mass moment of inertia I into alpha, angular acceleration. Torque is I alpha. Then put the values. Alpha equal to WL by 2I, WL divided by I value we got 2 into I is W by G L square by 3. So finally W cancel, L cancel, 3G by 2L. This is alpha value. Angular acceleration. We know angular acceleration alpha equal to, linear acceleration A equal to R into alpha. So linear acceleration A equal to, here R is the radius, here distance is L by 2. So you multiply L by 2 into alpha is 3G by 2L. Put the value 3G by 2L. So you will get 3G by 4. This is linear acceleration. We know force equal to mass into acceleration. So mass you can write W by G into acceleration is 3 by G divided by 4, G cancel, 3 by 4 W. This is force. So force is, we have to calculate reaction at A point. So RA is W minus 3 by 4 W. You will get W by 4. This is your answer. So from option, it's W by 4, W given 981 by 4, you will get 200, 245. B is your answer. Question is, the frictional torque transmitted in a conical pivot bearing considering uniform pressure, R is radius of shaft, alpha is semicone angle of cone, mu is coefficient of friction, W is load on bearing. This is direct formula. Uniform pressure theory, you have to use frictional torque. TF is 2 by 3 mu WR cosec alpha. This is direct formula. A mass of 2 kg is attached to two identical springs, each with stiffness K equal to 40 kN per meter as shown in the figure. Under frictionless condition, the natural frequency of the system in Hertz is closed to. In Hertz, you have to answer. This is parallel connection. So K equivalent equal to K plus K, you will get 2K. In Hertz you have to calculate, so it's omega n by 2 pi. Omega n we know, K equivalent by mass root over, then 1 by 2 pi, K equivalent is 2K, 2 into K value is 40, mass is 2 kg, 2 cancel, 40 root over by 2 pi, or if you take 2 inside, 40 by 4, you will get root 10 divided by pi, around, here it's kilonewton, so multiply 10 to the power 3. If you multiply 10 to the power 3, then you make it as 1 by 2 pi, here again I am doing 1 by 2 pi 4 into 10 to the power 4 root over. So 2 into by 2 pi 100 by pi, so around 33. A is your answer. This question is very time taking question. So you better leave this type of question in Isro, but if they get, they will ask, you have to answer it. So I am solving this question. Load is here, eccentric load. So first, primary shear stress you have to calculate. Primary shear stress PP is total load is load, or P we can write P divided by total number of rivets is 4. So P by 4, P is 840 divided by 4, you will get, this is in Newton. This is your primary load. Then secondary load again you have to calculate. For secondary load we know load is proportional to distance. You have to consider CG here, CG point, G point. So this point is G point. Name the rivets 1, 2, 3, 4 like this. This distance is R1, then R2, R3, R4. We know P is proportional to distance. So P by R it's constant. Same for P1 by R1. For rivet 1 and rivet 2, rivet 3 like this. P3 by R3 equal to P4 by R4. We are considering secondary shear load, not primary. Primary already we calculated. And from here, eccentric load is here. You are applying load here. So we know, let this load is P. P into E equal to P1 into R1 plus P2 into R2 plus P3 into R3, P4 into R4. You can write it as P1 into R1 plus P1 into R2 square by R1 plus P3 into R3 square by R1 plus, from here using this relation where, so P4 by R4 square by R1, P1 by R1 into R1 square plus R2 square plus R3 square plus R4 square, it's equal to P into E. So P1, or we can write it as secondary shear load at rivet 1, it's equal to P into eccentricity distance into R1 divided by R1 square plus R2 square plus R3 square plus R4 square. Then put the values. R value first we have to calculate. All values are same, R1, R2, R3. This distance is 30. Here also 30. So R equal to 30 square plus 30 square, 30 root 2. Put the values. P is 840 eccentric load and E distance is 300 into R1 is 30 root 2 divided by 4 into 30 root 2 square. 30 root 2 square. If you solve this one, finally you will get 1500 Newton. You cross check this one. You have to solve like this. Maybe calculation is wrong. R1, R2, R3, then R4. Primary shear load, it will act like this. 1 point, 2 point, third and fourth. Secondary load is acting clockwise, so secondary it will act counterclockwise. So here you will get, it should perpendicular to this line. So here you will get, this is the direction of secondary shear load. Here you will get PP primary. Primary is same everywhere. Then secondary PS1. This is PS4. Here PS2, PS3. This is perpendicular and its direction is opposite to the eccentric load rotation. Here eccentric load is acting here, so it will rotate it clockwise. So secondary shear load is opposite to that of eccentric load rotation. It's counterclockwise and perpendicular to this distance. So here heavily loaded are 2 and 1. You can take any one. The shear load on the worst loaded rivet. Worst loaded is 1 or 2. So this is theta value. So resultant load is R equal to primary load plus P square plus Q square plus 2PQ cos theta. So resultant is primary square plus secondary square plus 2 into primary load into secondary load into cos theta root over. So primary load we already got. For 0.1 we are calculating. So 0.1 or 0.2 also you can take. Theta value is 45 degree. Both are 30 and 30 distance. So see 210 square plus secondary load 1500 square plus 2 into 210 into 1500 into cos 45 root over. If you solve this one, you will get 1655 Newton. This is very time taking. You better leave this type of question. But in GATE you cannot leave this. Method is lengthy, but you can solve it. So answer is 1655. Approximately this one. C is your answer. Match the following criterion of material failure under biaxial stress sigma 1 and sigma 2 and the yield stress sigma y with their corresponding graphic representation. So maximum shear, then maximum distortion, maximum normal stress. Maximum normal stress is this one. If you single you can calculate. It will come here like this. And different maximum principal stress theory or maximum normal stress theory, it will come like this. And for maximum shear stress theory, color I am changing. This will come. Black color is maximum shear stress theory, and maximum distortion energy theory or MDET, it will come and one thing you have to remember, most conservative is this one, minimum area maximum shear stress theory. Then this is for MPST, maximum principal stress theory, and in between maximum principal stress theory and maximum shear stress theory, this is MDET, maximum distortion energy theory. So Sometimes they may ask this one, which one is most conservative. This is answer is maximum shear stress theory. And for ductile material, both we are using maximum shear stress theory and maximum distortion energy theory. But which one is preferable? If they will ask, MDET is preferable because maximum shear stress theory is most conservative. So we are going for MDET. So in this question, maximum shear stress theory, this one, A with N, then maximum distortion theory, B with L, C with M. So B is your answer. This graph you have to remember. So this is the end of this paper. Thank you friends. Thank you for watching my video. Thank you.